Hello, this is my video for the final. I am Samuel Peel. Anywho, here, let's run this guy real quick. There's that. We'll go into that later. But, okay, so, sorry, those are all my files. So we start with the x variable, because I had to assign a variable for x. So we have the -1 to 20, stepping through every 0.01 times. And then I've got z, which is just extra because I didn't want to, it just worked for me better this way if I did exponent, which is e, and then to the power of 0.1 times x. Y is that function recreated that you asked us to recreate. Z, which is that exponential. And then since it creates little matrices down here, you have to do the dot multiplication. And then sine of x plus 0.5, and x is the variable up there. Then to get my minimum values, I assigned it to a y value and an x value. And use the function minimum, so min y. And then I hold on so I can plot both of these. And then I plot x and y, which x is the just the x-axis there. Units weren't specified in the question, and y is the actual line function. And then I changed the line color to black and line width to 2, just so it's a little easier to look at and a little more accurate to what you've given us. And then here's the little maximum, or the minimum, excuse me, value. I have to do x min here because I need to, when I do this, the minimum calculations, it gives me the location of the minimum x value. So I have to go into the x array to the minimum, like the location of the minimum value, and then that gives me what I was looking for. Then I have the y minimum, which is super nice. It just gave me the minimum value for y. And then a red dot that's pretty sizable, size of 20 there. Then I've got the title as question 1, x label and y label, exactly as you've had them in the document over here. And then I turn the grid on just to get it a little more accurate. So we have question 1, and then the labels y and x, the function itself, and then the maximum value down there, which I think looks pretty close to what you've asked for. And then let's move on to the function here. This is my Q2 function. So you call a function here, and then you specify the outputs you want, and then the name of the function that you would actually type in. And I have this as, it's pulling the data, as in like the read table, because you gave us a table in the ECG underscore sampling dot XLSX. I have that under variable data. And then for x, that would be my x value, is data dot time in seconds. So it's going into the data value and getting the values in the table that are under time in seconds. And then I have that swapped to seconds is equal to the I transposed x, so it's a straight array rather than a table. That's just what I'm more familiar with. And then I repeated that with data.estimated BPM and transposed that. And then that's the end of the function there. Then we move on to the big one. So here, let's just clear all here. Pardon me. Ooh. Wow, there we go. Clear all, and then we'll just close this figure. So we've got a clear workspace and all that. And then we'll run this. And that'll give us our new table here, which looks pretty neat. Again, getting the outputs from that Q2 function, which are my variables, and then hold on so I can plot things. Then I'm just plotting the variables I got out of that, which is both of those one by one, or not one by one, excuse me, but the arrays that my function gave me. And then I did the same thing I did to calculate the maximum value for the last one, which is giving it 2 values, using the maximum function, it gave me the location of the X max. So I just indexed into there Y max to get the Y max, and then a red dot, marker size 20, because it just looks nice. And then I've labeled them for time in seconds, beats per minute in BPM, and then the title, question 2, and then the grid, excuse my roommate. Grid is on, as you stated you would prefer in the questions. Now I have the inputs here, which is the input for the lower x-axis limit and the upper x-axis limit, which if we come down here, it's asking for. So let's set the lower one. We'll have it zoom in on that main thing there. So we'll do 150, typing in 150, enter, and then the upper x-axis limit, we'll do 200, and then click enter, and it should give us that new graph there that it's zoomed in on, which is cool. And then I set the x limits to I and p, which are those two inputs we just got, which changes the graph. And then I have z set to BPM time, which is my function down here, which takes the x and y values from that Q2 function and gets the size of the y array for every time that y is greater than or equal to 60. And then I want the size, like it would be row column. Since it's all columns, I go to size, comma 2. I do the same thing for here, which gives me the size of the y array, and then I multiply it by 100 to get a percent, and that outputs down here. The BPM was above 60 19.9597% of the time, which is this display here, which is display, and then BPM was above 60, and then I have to num to string because I get a number out of z BPM time, which is that percentage, and then percent of the time. And then finally here we have that structure as mystats is equal to BPM struct, which is down here. Function mystats is BPM struct. Gets the values from the Q2 function, and then it was super easy. Average BPM is mean y, minimum BPM is mean y, max BPM is max y, and standard BPM or standard deviation is standard y. And then I have that all put into a mystats struct. And then that's it about that. And I have that output, all of these here. And if I just wanted the maximum value, I could do my, excuse me, capital S struct, or my stats, parentheses 4. And then that would give me that maximum value right there, since it's the 4th value. And those are my little variables here. Since I needed, the size, it would be size y, and then 2 would be 496, and then the, while I was working on this, these, like, y is greater than or equal to 60 was a 99, it's a 1 by 99 array, so that just gives me the number 99. Here's some evidence of that. We'll do y for y is greater than, pardon me here. I'm not even left-handed, and it's super hard to do this with only my right hand, if you can believe it or not. Okay, so that's y for every time that y is greater than or equal to 60, and that's 99. Our answer is a 1 by 99. And then that size function just gives me the number 99 rather than an array like that. And then we get, after setting our max and mins for the x boundaries, we have the title, question 2, which is beats per minute in BPM, time in seconds, and then our new limits, which was 150 to 200, and the maximum value right there, which is the maximum number, or maximum beats per minute, which is 76.9213. That ought to do it. Thank you for your time.